A real gem fell into my hands recently. This Fender Princeton Tweed from around 57 to 60. This one has the popular 5F2A circuit, or at least I thought it did. The owner said it was making a lot of noise and didn't really work very well. The Tweed is, worn out in the corners and has really yellowed over time, which it will do. Fender sprayed all the Tweed with lacquer, several coats of nitrocellulose lacquer, and that particular type of lacquer yellows over time. It's actually in pretty decent shape for its age, and I would not even think about recovering this amp. The control panel looks good. It's basically original. It's got the tone control there, which set it apart from the Champ, which was made in the same era, but it did not have a tone control. Otherwise, the circuits were very similar over the years. The handle looks like it's been replaced, maybe even the hardware too. It's definitely not original. And looking at the back, you can immediately, at least I could immediately tell that it had been modified and modified a lot. In fact, it was abused severely, in my opinion. I don't understand why anybody would do something like this, but they did. So this circuit is no longer a 5F2A. What they did was an attempt at turning this Tweed Princeton into a Tweed Deluxe, which is a push-pull, which means they had to change basically the whole circuit, including the output transformer. And as I'll soon discover, the power transformer has also been changed. And you can see that those diodes there, they never used diodes back then for these kinds of amplifiers. It was rectifier tubes. He made sure all the labels of the components were turned over so you couldn't see what they were. I don't understand that. I would never do it. In fact, I make it a point of making sure all the labels are exposed so the next guy that has to work on one of these will know what he's dealing with. This amp has been sitting up in my customer's attic since the early 80s. And I recently built a new Deluxe 5E3 for him, and it prompted him to go up there and drag that thing down and ask me if I could fix it, which I said, sure, get it over here. And there you see the label that it's definitely a Princeton Model 5F2A. At least the label is, not the rest of it. So I'm going to pull it out and get the chassis up on the bench and take a closer look at everything and see what it is we're going to do with it. So the first thing I want to do is look at these transformers and get the numbers off of them and identify them. I'm almost positive that output transformer is going to have to be replaced because it's for a push-pull, and we're going to go back to a single-ended. But the power transformer, at least my thinking was at that time, was that I could still use it. So I traced it out and looked it up, and everything seems like it would work fine. And then I looked at what was originally going to be in there, and I didn't see anything that stood out that was such a major difference. So I thought, well, no, there's no sense buying a new transformer for it if the one that's in there is going to work. So next I'll look up the output transformer, and since I know I have to change that other one, I have to see what it is I want to put in there. The 1750C is probably the original one. It's a 3.2 ohm output, which my customer really doesn't want that. He wants the 8 ohm. So I happen to have a 1760C, which is basically the same transformer, except it's a multi-tap output. It has the 8 ohm output, which is what he wants. So looking at the inside a little bit closer, I can figure out what it is I'm going to try to keep and what I'm going to get rid of. And I'm not going to keep much. That whole circuit across the middle here is going to go away. This transformer does not have a center tap for the filament circuit. So he has the virtual ground. Those are probably 100 ohm resistors going to ground. And the 5 volt filament wires that used to go to the rectifier tube, they're tied off because he put solid state rectifiers in. So I'll keep the existing pots. The input output jacks will stay. Probably get rid of the tube sockets because they get worn and they don't make very good contact over time, and they're really hard to get tightened up and cleaned. So I'll just change those out and put some new sockets in. We're getting new tubes anyway. Out with the old, as they say. So this is what we're starting with. While I'm waiting for all the components to be delivered, which I have ordered, I'm going to do a couple other things that I need to do. This amp did not have an upper back panel, so I'll make a new one using the CNC router. And here I'm going to make a adapter for the speaker. The speaker that's in there is a 12-inch, and he decided on a 10-inch. Some of the Princetons did have a 10-inch. I just don't remember if those were actually from the factory with 10-inch or those were mods that people had made. But he wants a 10-inch 8-ohm speaker in there, so we'll just make an adapter and slip it in through the back. That way I don't have to pull the grill off and change the cloth and all that. That would be too much work. Plus, I want to keep that original cloth. I'm going to go ahead and put the tweed on that back panel. But I don't think I need to show it. I'm not going to do a tweed installing video here. So to try to get the tweed to match, I used some toner from Mohawk to darken it up a little bit. You can see there's the contrast between the new tweed and the old. So I darkened it up. It looks pretty close. So our components came in from Antique Electronic Supply. And the first thing we'll do here is drill out the eyelet board, which I do on the CNC router. Fender did not use turret boards like Marshall. They used eyelet boards, which work just as well. After we drill the board, we will install the eyelets, and that doesn't take very long. Just put them in and flip the board over and flare out the back side of them so they stay put. That's my little homemade tool. It's just ground to a kind of a point so it flares out the back side. Works great. So next we are going to start populating this eyelet board with all the new components. We'll start with the power supply filter capacitors. I like using the F&T for this. These are good capacitors. This large one is actually 2 capacitors because some of the components that were available back then are not as easily found these days, and the schematic called out for 2 8 microfarad capacitors in this position, and the only thing I could get my hands on was a combined. There's 2 8 microfarad in there, and so it accomplishes the same thing. You can see that Princeton layout there, and I'm trying to stick to that absolutely as closely as possible. The effort here is to return this back to what it would have sounded like back in 1960 or 59 when it was made. So I'm going to try to make sure that everything is the same. Some of the resistor values have changed, but they're probably undetectable in terms of tone. So we'll get the chassis ready to install the new eyelet board. I've got some little standoffs that I use for that. Now we'll get the eyelet board set in place and start wiring. My color scheme is black is ground, green is filaments, red is B+, and yellow is signal. I did add a standby switch to the front panel at the customer's request. He uses that standby switch a fair amount on his other amplifiers, and wanted to make sure there was one on this amp too. So it's time to plug this thing in and test it. I always start out with it plugged into the current limiter, and then I start testing my AC voltages without any of the tubes in place. Make sure those are all correct. Yeah, I have my meter out of the view, so you'll just have to trust me when I tell you the filament voltages are correct. Next, I'll put the rectifier tube in and check my high voltage, which I will not show because I broke a cardinal rule by having two hands in the chassis with high voltage in there. So I'm not going to show it. So now I'll get the tubes plugged in, and using my bias probe, I will do one last check while I'm on the current limiter. Because when I actually go to bias the tube, you don't want to be on the current limiter for that because it's an incorrect reading. So I'm going to go ahead and check the bias on the output tube. We're all connected. I don't have a very good view of this. You can only see 1 meter, but it's way over biased, I can see already. So I've got 46 milliamps at over 400 volts on the plate, so that will not work. This is where I discover that this output transformer is just too high voltage for this application. In the previous amp, they had 2 output tubes which drew the voltage down enough so that it would work, but my cathode resistor is already too large, and I don't want to make, I would have to add so much resistance to it that the voltage would just go way up then. So I can't use that transformer. So this is the proper transformer for the Princeton Tweed 5F2A. So I'm going to go ahead and get this hooked up. So we're ready to run the bias test again. So we'll switch it on and see what we get. So we have 342 volts at roughly 40 milliamps on the plate. So we'll do a little math. 342 volts times 0.04, and that is 13.68 watts of plate dissipation. This tube wants to see 14, so I think we're going to call that good. On a single-ended amplifier like this, you can go ahead and push that plate dissipation right up close to the maximum, and it doesn't hurt a thing. So we put everything back together, and this is how it came out. That grill cloth looks a little edgy, but so does the rest of it. So I didn't change any of I didn't try to clean any of that. No, I would keep it just like that. The only thing that's different about it is I had to make a new top on the back side there. But I think I got the color right. So the only thing to do now is to do a little sound demo and try to show off the clean tones of this Princeton amplifier. We'll be using the Stratocaster with a little bit of reverb, and then straight into the amp with an SM57 for the microphone. This is the intro to Josie by Steely Dan. If you're expecting me to sing, forget it. You wouldn't want me to. So anyway, that's a wrap, and thanks for watching.